Okay, I think that now we can start our webinar. So we want first to welcome everyone to this new and last webinar of the year. My name is Rafael Fernandez. I am working as a research fellow at the UCL in the UNESCO Chair in Disaster Risk Reduction and Resilience Engineering. Today we have a webinar that is titled Navigating the Salinity Crisis, Challenges of Saline Water and Soil in Coastal Bangladesh Amid Rising Sea Levels with Dr. Mohammad Shamsuda. Before I give him the word, just to mention that we have several upcoming webinars. After this one in December, the last of 2024, we have already scheduled 4 different webinars. By the end of January, we will have one by Professor Solveig, titled Infrastructure Resilience Assessment Using System Dynamics and Agent-Based Modeling. Then in February, we have a webinar by Professor Solomon Tesfamariam on tall timber design under earthquake and fire loads, different practices in the past, future, in the present and the future. Then in March, we have Dr. Sinan Akar. He will talk about academic and professional approaches to to catastrophe modeling. And in April, we have Dr. Sonia Giovinazzi from ENEA talking about multi-criteria life cycle approach for school infrastructure improvement in the Kyrgyz Republic. So in here you can see the website. In our website you can find all the information on the upcoming webinars, and you can also find all the recordings of our past webinars. You will also find the recording of this specific webinar, and I hope to see many of you in our future events. So without further ado, I'm going to introduce today Professor Mohammad Shamsuda, commonly known as Shams. Shams is a professor of water crisis and risk reduction in UCL's Department of Risk and Disaster Reduction. And all the research, or his main focus in research, is water insecurity risk to sustainable development and climate resilience. He works in particularly on insufficient water storage, freshwater storage, and quality risk for food security and human health. Professor Shams have worked in different regions in different countries across South Asia and Sub-Saharan Africa, working on fostering interdisciplinary collaboration with different practices, with engineers, experts, climate scientists, and so on. He has published more than 70 scientific articles, and his work has more than 7,500 citations. Professor Shams has also contributed to the IPCC 6 assessment report, specifically on water. Um, and it's my pleasure to have you here. To thank you very much for accepting being part of this webinar, Shams. And please go ahead. The floor is yours. Thank you again.
Thank you very much, Rafael, for the introduction. Let me share my screen. Okay. Just give me a second. Okay. I hope you can see my slide and you can hear me fine. Give a thumbs up.
Yes, all good,
Great.
Shams. Go ahead.
All right. Thank you very much. I'm going to just park it here. Great. So, thank you all for joining me in this webinar today. As Rafael has already introduced, I'm not going to introduce myself again, but just want to say a few words before I begin my presentation. So I'm Shams, based at UCL, Department of Risk and Disaster Reduction. By background, I'm a geologist with a specialization in groundwater science, otherwise known as hydrogeology. And I came to the field of disaster risk reduction from the kind of geology and hydrogeological background. And I do work very interdisciplinarily with colleagues from various different fields, including engineers. I know the audience here may come from engineering background, um, which I'm quite mindful of. But again, my talk is very much on environment and geological aspects of the topic, which is soil and water salinity crisis in coastal Bangladesh. So without further ado, let me introduce the seminar outline here. So my presentation is divided into 4 sections. Um, I will begin my presentation by giving you an overview of water and soil salinity. Um, we all know that this is viewed as a very much environmental issue, but I would like to introduce water and soil salinity as a natural hazard. Um, it's it's a topic that is debatable because there are sometimes anthropogenic drivers of water and soil salinity, but the particular case study that I'm going to present to you today from southwest coastal Bangladesh is primarily a naturally occurring problem. So, with that kind of background, I would like to call it a natural hazard. So, in my presentation, I'll be giving you, as I mentioned, the case study of water and soil salinity from coastal Bangladesh. And I like to acknowledge a few colleagues and my PhD students who are working on water and soil salinity issues in their PhD work. So much of the work that I'm going to present in this webinar actually comes from the 2 PhD students who are working with me. And then I also present some research that my colleague, Professor Kazimuddin Ahmed from Dhaka University in Bangladesh, has also contributed. And hopefully towards the end of my webinar, I will have Professor Kazimuddin Ahmed with us here in the panel. And he has accepted the invitation, so hopefully he will be there to take a few questions when we go to the Q&A part of the presentation. So let's begin this presentation by giving you an overview of water and soil salinity hazard. Why do we need to care about water and soil salinity hazard? As you can see, soil and water salinity affects life and livelihoods through a number of different pathways. So for instance, high salinity in water and soil can affect degradation, can affect water resources through degradation of freshwater resources. So for instance, high salinity can contaminate ponds, lakes, and rivers. And high salinity can also affect adverse health outcomes. Exposure to high salinity through primarily through water can cause a number of health issues. Water high salinity and water can also cause food insecurity through reduction in agricultural production. It can affect aquaculture and biodiversity, land degradation, economic losses, infrastructure damage, environmental damage in terms of ecosystem disruptions. Finally, water and soil salinity can actually cause human displacement and migration through loss of livelihoods and lands. So you can see that there are multiple uh, areas that can be affected because of high salinity and soil um, in the environment. And there are several drivers that can affect our water and soil salinization. Many of these are actually natural drivers. So for instance, um, water rock interactions, sea level rise, coastal flooding associated with cyclonic storm surges, and um, and there are also some anthropogenic drivers that can affect water and soil salinity. I'm not going to talk about those drivers in my presentation more in detail, but I just thought it might be a good idea to refresh our memories on some of these areas where water and soil salinity hazard can affect and some of these drivers. So in the interest of time, I'm not going to talk to you about all of these different areas where water and soil salinity can affect, but I'm just going to highlight a couple of them. So let's begin with the first one is why water salinity is essentially a health problem. So we can have various adverse health outcomes because of the exposure to very high salinity through primarily through drinking, but also through contacts. This is the list. Again, you can see it's a long list of health outcomes that is associated with exposure to very high salinity in drinking water. For instance, high salinity consumption can cause high blood pressure, preeclampsia, and eclampsia, which is a condition that is found in pregnant women in their last trimester. It can lead to premature birth, women's reproductive health issues, skin diseases, diarrheal, and other diseases. So the list is quite long. And the graph, the pie chart here on the right-hand side shows the number of cases um, in maternal death causes in Bangladesh. And you can clearly see preeclampsia is one of the key um, causes for maternal death in Bangladesh. And it is uh, primarily because of the exposure to very high salinity, particularly in the coastal area of Bangladesh. The second reason why we should be caring about water and soil salinity is because it affects food security. So food insecurity risk is very much there because of the high water and soil salinity and increased risk of salinization of water and soil resources. And again, I'm not going to go into detail, but I just wanted to let you know that yes, high soil and water salinity can reduce crop production. It can cause soil to become less fertile. It can also shift to salt tolerant, low value crops. And there could be issues around livestock feed, fisheries, and ultimately losing income. And in coastal Bangladesh, about 30% arable land is located where soil salinity is already influencing um, some of these adverse issues around food security in Bangladesh. So these are the couple of reasons why I think it made it very clear that why should we care about water and soil salinity as an environmental or a natural hazard. Now let me introduce Bangladesh. Those of you who are not familiar with the geography of the country, Bangladesh is actually located in one of the Asian megadeltas, particularly the Ganges, Brahmaputra, and Meghna Delta. This is also known as the Bengal Delta, as you can see from the image below that it is a very flat, low-lying land bounded by India in most part. We do share a border with Myanmar in the southeast of Bangladesh. And it is a very low lying topography, and uh, it is actually one of the most densely populated countries in the world. And why, again, it matters because uh, because population is exposed to water and soil salinity in Bangladesh. As you can see from the image here that shows population density in the region, particularly in Bangladesh, you can see that there are a number of cities. Uh, in Dhaka city is particular, which is not a coastal city, which is quite several hundred kilometers from the coast, is not directly exposed to very high salinity naturally. But if you go to West Bengal part of India, Kolkata, which is also a megacity, which is in the coastal area where water and soil salinity is an issue. Also in the coastal area of Bangladesh, we do have number of towns and cities. About 35 million people live in the coastal area of Bangladesh who are directly exposed to water and soil salinity in Bangladesh. This is a typical landscape of the coastal area of Bangladesh. If you are from the region or if you have visited the coastal area of Bangladesh, you will see that there are water bodies everywhere. Farmers do produce brackish water prawns. Shrimp cultivation is one of the very lucrative businesses in the coastal area of Bangladesh. You will see people using boats as a mode of transportation, but at the same time, you will see lush green croplands. So rice is grown in coastal areas, and which is primarily grown through groundwater-fed irrigation. There are a number of kind of water-related issues, as you can see from the images at the bottom. So there is a very strong seasonal variation in rainfall in Bangladesh. It mostly rains during the 4 or 5 months in the monsoon season, when 90% of the rainfall falls between May and September. But then again, when it comes to dry season, so for instance, December, January, February, March, April, when there is very little rainfall, there is a seasonal water scarcity. As you can see from the image, bottom left-hand side, a woman is collecting water, which is quite turbid and which looks to be not a very good source for collecting water. And then when it comes to flooding, which we often do in Bangladesh during the monsoon season, you are very much then dependent on groundwater. In many places, even groundwater is quite saline in the coastal areas. And then you can see that often people living in the coastal areas collect their household drinking water supply from various vendors. So in this case, a queue you can see of women and children collecting their drinking water from a water vendor, which is quite also common in the coastal area of Bangladesh. Now, looking at the science a bit, again, drawing from research that my PhD students are doing here at UCL. So I'm going to present some of their work to show you how we can characterize water salinity and soil salinity in Bangladesh. So here is a map on the left-hand side. You can see that shows surface water salinity in Bangladesh. And you can see that the coastal part, primarily the southwest coastal part of Bangladesh, suffers from very high concentration of salt in surface water. When I say surface water, I primarily mean rivers, and you can see that the salinity can be also quite seasonal, as you can see from the graphs on the right-hand side. So here there are 6 kind of sites that I selected to present the seasonality in surface water salinity. And you can see that in some areas, particularly SW1, which is located in the southwest part of Bangladesh, just southeast of Khulna, where salinity can be very highly seasonal, and the surface water salinity can vary from several hundred microsiemens per centimeter to up to 12,000 or more microsiemens per centimeter. So there is very high seasonal variation in surface water salinity. In other places where salinity is generally quite low, less than 500 or 1,000 microsiemens per centimeter, we do not see very high seasonal variation in those areas. So it's the same map looking at on the left-hand side, but on the right-hand side, we are looking at long-term trends in surface water salinity that my PhD student, Izaz al-Haq, has published recently in Frontiers in Water journal, he looked at long-term observation data from Bangladesh Water Development Board, which is a government agency in charge of monitoring countries' water resources. So they collect surface water salinity every month in number of different places in the coastal areas of Bangladesh. And in this particular map, we are looking at long-term variation in surface water salinity, and you can clearly see that the southwest part of Bangladesh, south of Khulna, places around the Sundarban areas, surface water salinity has over the years increased quite substantially. It has also increased in the southeast coastal part of Bangladesh around Chittagong area, and it has also slightly increased in the areas in the kind of south central part of Bangladesh. But in the rest of the country, further away from the coast, surface water salinity is not a big problem or not a problem at all. When I look at groundwater salinity here, the map on the left-hand side shows the regional distribution of groundwater salinity, and you can clearly see that the coastal aquifers are uh, primarily the shallow part of the coastal aquifers are contaminated with very high salinity. We're talking about 5,000 plus microsiemens per centimeter. When the drinking water kind of guidelines, there isn't any WHO, World Health Organization standard for drinking water salinity, but the general guidelines is around 1,500 microsiemens per centimeter should be the ideal salinity concentration in drinking water. So you can see that clearly the whole of the coastal area of Bangladesh, where the shallow groundwater can be quite saline. And on the map on the right-hand side, you can see the salinity in deep groundwater. Again, you can see that it varies from place to place. But even the deep groundwater, when I say deep, it's greater than 150 meters below ground level. You can see there are areas in the coastal area of Bangladesh where concentration of chloride in this particular case is very high. And the WHO standard of chloride is 250 micrograms per liter. So you can clearly see that there are a number of areas where chloride concentration in groundwater is very high. So finally, soil salinity here, the map on the left-hand side shows soil salinity concentration in Bangladesh. Again, you can see it is a problem primarily in the coastal areas. As you go away from the coastal area further inland soil, there isn't much soil salinity issue in the country. So my PhD student, Ahmed Rahman, is looking at both soil and water salinity, and he's developing a composite salinity hazard map, and he's also looking at assessing the soil and water salinity at the national scale in Bangladesh. And this is one of the very first attempts to produce a composite salinity hazard map of Bangladesh, combining information on soil salinity, surface water, as well as groundwater salinity. So this work is still ongoing. We haven't published this work yet, but hoping to get it published in the coming year. Now, I'm going to focus a bit more on the southwest region, where Ahmed, in his PhD work, has collated some very rare long-term record of soil and surface water salinity. So here he has collated 11 um, time series record of soil salinity and 13 surface water salinity from SRDI, which is the Soil Resource Development Institute in Bangladesh. And we have also collected meteorological data from Bangladesh Meteorological Department. So let's have a look at the long-term time series record of surface water and soil salinity in the southwest of coastal Bangladesh. Here you can see long-term record from 3 different study areas. All are located in the hotspot of soil and water salinity. And you can clearly see that there is a very strong seasonal variation in soil salinity. So the blue line here shows surface water salinity, and the red line shows soil salinity, and the blue bars in the background shows rainfall. And you can clearly see that there is an inverse association between rainfall and surface and soil salinity. So soil and surface salinity increases in the dry season. So in March, April, May time, concentration of salt in soil and water reaches its peak. And then when it starts to rain in the monsoon season, from May, June time, you tend to see a very sharp decline in salinity. Uh, so we have been able to see this very strong seasonal dynamics because of the long-term records that Bangladesh Soil Resource Development Institute have been collating, and they shared the data with us, with Ahmed in particular, for his PhD work. This work has not been published yet. We are currently writing it up as a chapter to show the seasonal, very strong seasonal dynamics in both soil and water salinity in Bangladesh. Let's look at the same time series records, but this time with temperature in the background. Again, you can clearly see that the um, peaks of soil and water salinity correlate quite well with the peaks of temperature. So in Bangladesh, normally April, May, March, April, May are the months where temperature uh, reaches its peak. Um, Even though the temperature stays quite high throughout the monsoon season, but because of the rainfall effect, you tend to see reduced concentration of salinity in both soil and water. Again, this graph here basically shows that the rate of change in 2 consecutive months in soil salinity on the top diagram and the water salinity in the bottom diagram. And you can clearly see that very sharp change happens in soil and water salinity at the beginning of monsoon in June, when in a matter of a month, several thousand microsiemens per centimeter worth of salinity can actually drop uh, because of very high monsoon rainfall that happens during the month of June and July. Soil salinity drops quite quickly in a matter of a month, whereas surface water salinity takes a bit longer because these channels are tidal channels. So you have the tidal influence affecting the reduction in soil salinity, in water salinity. Um, Let me know if I lose the voice because the headphone is running out of battery. So let's carry on and see how far it can go. So here we also looked at long-term trend in soil and water salinity. Here, one particular example that shows that there is a very interesting trend in the long-term soil salinity data from one of the study areas. And here you can see that between a period of 2004 and 2022, soil salinity decreases in the first part of the time series, and then it started to increase in the past decade. And we have seen this similar pattern in other locations as well, both in soil, primarily in soil, and not so much in the water salinity. Uh, we also looked at the associations between cyclones and soil and water salinity. Here in this graph, you can clearly see that the timing of tropical cyclones and the time series of soil in the top diagram and water salinity in the bottom diagram. And you can, if you look very carefully, you can see that cyclones do have an impact on both soil and water salinity, but it's very subtle. It also depends on the timing of cyclones in Bangladesh. Normally, we see cyclones during pre-monsoon season, so March, April, May time, but we also see cyclones happening after the monsoon, that is November, October, November, and December time. What we have observed in this analysis is that the cyclones that make landfall during the pre-monsoon or the early monsoon season, namely in um, April, May time, tend to have greater impact on water and soil salinity as opposed to the post-monsoon season when you already have very low salinity level in soil and water. Cyclones tend to have less impacts. Now, moving on to the other drivers, such as the rising sea level and sea salinity. Here, we also looked at how um, rising sea levels are having an impact on the seasonal and temporal dynamics in soil salinity. So here we are looking at long-term time series record of sea surface sea level anomaly, so which is basically showing there is a very strong seasonality in the sea levels as well, which reaches its peak during August time, and the lowest sea level is observed during February, March time. And there is a very strong seasonality, as you can see from the maps on the top right-hand corner as well. We also looked at sea surface salinity as well from modeled as well as observed, so a reanalysis product from Copernicus. And you can see very clearly there is a very strong seasonality in sea surface salinity in the Bay of Bengal, which reaches its peak around April, May time, and the lowest salinity in seawater is found during October time. So there is a very strong kind of seasonal variability in sea surface salinity as well. So if we combine the two, you can clearly see that there is a very kind of inverse association, if you like, in the sea level anomaly as well as sea surface salinity over the long period of time. We have observed a steadily rising sea level at the rate of 3.5 to 4 millimeters per year, whereas we have seen over the same period of time a slight decrease in sea surface salinity. And the maps on the left-hand side shows the spatiotemporal trend in sea surface sea level as well as the sea surface salinity. So the association between sea surface salinity and sea level is quite inverse in the kind of temporal seasonal dynamics. So we combined all of these factors together in a statistical framework and try to do a model to explain variability in soil salinity as well as surface water salinity. This is just a snapshot of the modeled coefficients and the statistical significance of the model outcomes. Without going further into the detail, I can tell you some of the key model associations that we have found in this work is that the models show uh, temperature, rainfall, and sea level anomaly and sea surface salinity, as well as groundwater levels, are the important predictor of soil as well as river water salinity. So, for instance, temperature has a statistically significant positive association with soil as well as river water salinity. And you can see that the temperature itself explains 7.3% variability in the seasonal variation in soil and water salinity. So a 1 degree increase in temperature can actually increase 7.3% salinity. And in the months in the kind of dry season, when the temperature increases by several degrees, you can imagine that that it proportionally increases both soil and water salinity as river water salinity as well. We have seen very interesting association with sea level as well as sea surface salinity. So, for instance, the sea surface salinity has a very strong positive um, association with both soil and water salinity there. Finally, we are currently looking at how the changes in long-term temperature as well as rainfall might affect soil and water salinity in Bangladesh. So here I'm showing you the maps that show that basically shows long-term trend in temperature as well as rainfall uh, for the period of 1961 to 2021. So basically, in a 60-year period, we have clearly seen that there is a very uh, uh, clear increase in temperature in 34 meteorological stations where we looked at, although there are some variations. In couple of sites, there is even a marginal decrease in temperature. But on the right-hand side, the map basically shows a long-term trend in rainfall over the same 60-year period. And interestingly, you can clearly see that the coastal stations are all showing an increase in annual rainfall over the last 60 years. We haven't quite looked at how this long-term changes in temperature and rainfall might affect uh, the soil and water salinity. But what I can tell you, though, from the preliminary analysis that my PhD student has conducted so far, is that we have seen that June rainfall in particular in coastal Bangladesh is consistently decreasing over time, but then July rainfall is substantially increasing. Although overall the rainfall is increasing in the coastal areas, but this variation in month-to-month rainfall um, will have an impact on soil salinity, and indirectly it will have an impact um, on food production, essentially in the coastal area of Bangladesh. Now, moving on to some of the kind of adaptations, what people have done so far to mitigate the water and soil salinity in coastal Bangladesh. So here I'm showing you some of the um, adaptation in particularly in agriculture, what farmers in the coastal areas are trying to do to mitigate soil and water salinity in the coastal area. So you can see that in recent years, farmers are growing watermelons as opposed to rice because they are finding a good profit when they grow watermelons. And of course, watermelon takes less water than producing the dry season buru rice, which is quite high yielding. And similarly, you can see farmers are also growing maize. They are also growing sunflowers. and pumpkins and some kind of beans throughout the coastal area of Bangladesh as a kind of adaptive measure to mitigate high salinity in water um, and surface water in particular. There are other adaptation measures that farmers are doing throughout the coastal area. So, for instance, floating bed for vegetation production. You can see that in some areas, particularly in waterlogged areas in the coastal area, farmers do it seasonally. When they have a waterlogged flooded land, they create this floating bed where they produce different vegetables. But again, this is not very widespread. You can almost say we kind of cherry picked some of these examples where farmers are doing. But when you think about the coastal region as a whole, and if you think about the 35 to 40 million people living in the coastal areas of Bangladesh, these adaptation measures are actually not happening to the scale to meet the growing demand for food. But nevertheless, these are some of the adaptation measures farmers are trying in different parts of the coastal area of Bangladesh to mitigate the soil and water salinity issues. There are a few other examples. So this is a flying bed where farmers do produce vegetables. So this is an example from a coastal district of Khulna, where a farmer is producing seasonal vegetables because when the soil is salty, you cannot grow much crops in that soil. In that case, you create a flying bed with soils um, that has less salinity in it, and essentially you can use as a kind of adaptation measure to produce seasonal vegetables. But again, this is just an example. It is actually not happening at the scale that is required to address the food insecurity issues. This is another example where you can see farmers are trying feature irrigation, where they are trying to save the irrigation water as much as they can, because in the dry season there is freshwater scarcity. But this is how farmers are trying to adapt to the changes in their irrigation practices to produce vegetables and seasonal crops. This example is also from the Khulna district, which is also quite badly affected when it comes to soil and water salinity. Another example is called a mulching process, so where farmers try to reduce the evaporation loss by covering the soil with straws and other materials. And this is just to save irrigation water that is required to produce seasonal crops. And the figure on the right-hand side, where you can see a woman is watering mangrove plants. This is happening throughout the coastal area of Bangladesh, where various types of plants associated with the mangrove forest are grown in different parts of the coastal area of Bangladesh, because mangrove forest can prevent the adverse consequences of cyclones that often hit the coastal part of Bangladesh, because they are much more kind of strong and sturdy and resilient, and they provide the natural protection from cyclones and associated storm surges in coastal area of Bangladesh. Again, is it happening everywhere uh, at the scale that is needed? My observation is no. But nevertheless, this is something that the local communities are trying alongside various NGOs. They're helping, and also government departments are also helping them um, to grow more mangrove plants in the coastal area that can provide a kind of natural barrier to cyclone damage in the coastal area. So here, uh, basically, that this is the list where there are a number of different kind of engineering solutions that people are doing throughout the coastal area of Bangladesh. So, for instance, desalination through reverse osmosis is happening in some parts of the coastal area. Rainwater harvesting is happening. Freshwater storage, so where um, freshwater is being stored in the underground aquifers through managed aquifer recharge, which I will explain in a moment, is also happening in different parts of the coastal region to mitigate the soil and water salinity effect. So there are a number of different other kind of engineering solutions out there that uh, authorities and the coastal communities are trying to apply in the coastal areas to mitigate soil and water salinity. But again, when it comes to scale, there is a lot of work to be done to increase the scale to a level that can actually provide protection to the exposed coastal areas in Bangladesh from the adverse effect of cyclones and the slowly rising sea level that is posing a threat to the uh, soil and water salinity in the coastal area of Bangladesh. In the interest of time, I'm going to go very quickly and show you some of the measures that I already listed. So, for instance, in the coastal area, people are using pond sand filters where they pump water from a pond, a freshwater pond, and then they filter it out through a sand filter. And the water that comes out of the filter is of good quality and clean, relatively clean. So this is one of the measures that in the coastal area people are trying uh, to um, to mitigate the effect of freshwater scarcity, particularly in the dry season. So rainwater harvesting is one of the things that measures that people are trying in the coastal communities, storing water in different features and storage in the monsoon season, and then trying to use it in the dry season. But then again, there are lots of issues associated with the maintenance of these systems um, that people are experiencing in the coastal areas. There are water vendors these days, so who collect water from primarily from groundwater, and they store it in large tanks, and then they basically sell it uh, to the coastal communities. There is water ATM, is a new kind of um, system that is introduced by various NGOs as well as the government organizations in Bangladesh, where essentially you can collect uh, uh, fresh water by paying through the ATM. There is also reverse osmosis, as I mentioned. People are using reverse osmosis technique to desalinize salt water, and it is happening at very small community scale as well as household scale through various reverse osmosis water filters. And then finally, one of the measures that my colleague, Professor Kazimuddin Ahmed from Dhaka University, has pioneered a technique is called the managed aquifer recharge. So, which I'll be explaining in a moment. So again, just to show you some of the water adaptations. So here I mentioned about water harvesting. You can see that people are storing water in large water tanks, plastic tanks during the monsoon so that they can use the water after the monsoon season when there is very little or no rainfall in the dry season. And it is happening at the household scale and also happening in some places at community scale where people are actually storing water in large storage tanks. This is a pond send filter that I mentioned. You saw the picture before. Again, there are lots of kind of technical and cultural issues associated with the operation of these ponds and filters. Many of these have actually failed to sustain over a long period of time because of the cumbersome and time-consuming maintenance issue with them. This is a reverse osmosis plant in Khulna district in Dakop, and you can see Ahmed standing there in front of the ATM booth where people are actually collecting fresh water that is coming out of this reverse osmosis desalination uh, technique. And finally, in the kind of less 5 or 10 minutes I would like to explain one of the techniques that my colleague and my mentor, Professor Kazimuddin Ahmed from Department of Geology, University of Dhaka, has pioneered with the Department of Public Health Engineering in Bangladesh, funded by UNICEF, where they uh, have used this managed aquifer recharge engineering technique to store fresh water from ponds, fresh water from rainfall, to store it underground in an aquifer during the monsoon season and use it during the dry season. So here, this is a schematic that shows how fresh water is pumped from pond through a sand filter, and it is stored in an aquifer at a reasonably shallow depth. And that uh, aquifer, which is salty otherwise, is getting fresh water through this managed aquifer recharge system, and it creates a bubble of fresh water around the injection well throughout the monsoon season, and then people are allowed to use during the dry season from this freshwater lens that is created within a saltwater ambient and saltwater aquifer. And these are some of the ponds from where freshwater is used. As you can see, it's very turbid, it's dirty water. And this is towards the end of the kind of dry season when fresh water is reducing quite fast. And this is the water you collect and you pump it through the managed aquifer recharge technique into the underground aquifer system to create this freshwater bubble. And it is done through local technology, so where you have local drillers using a very kind of rudimentary platform that is made up of bamboo structure, and a team of 6 to 10 people can install wells in a matter of a day or a couple of days. So my colleague, Professor Kazimuddin Ahmed, and his team worked with the local drillers to install around 100 managed aquifer recharge schemes around the coastal area of Bangladesh over the last many years, and some of them are working very well. I'm going to mention some of the challenges that this particular scheme has faced in sustaining in the coastal area of Bangladesh. But this is just an example here where you can see that the fresh water is pumped from a pond and it goes to a tank where the tank has layers of sand that works as a filter. And then the water that is the filtered water is that the pump into the aquifer through through a number of injection wells that goes under gravitational force to create the freshwater bubble during the monsoon season, and then you use it during the dry season. And this is the managed aquifer recharge has been providing also water during flood season. So it can be seen as a kind of climate or extreme weather resilient water supply system in the coastal area of Bangladesh. But I briefly mentioned that out of 100 schemes that Professor Kazimuddin Ahmed and his team has constructed throughout the coastal area of Bangladesh, around 50% of them are currently operating. So the main reasons what my colleague and his team found that the local communities, when they have been handed over the schemes, they are in charge to manage these MAR schemes. They find it a bit cumbersome because there is a maintenance cost involved, there is maintenance time involved, and often they don't necessarily see the value and benefits of this public water supply infrastructure that otherwise provide fresh water during the dry season when there is serious scarce of fresh water, as well as when there is flood time, people can access groundwater during the flood time as well, providing kind of climate resilient, if you like, water supply systems. But because of these various kind of socioeconomic issues, many of these schemes are not operating successfully. But nevertheless, going forward, many lessons can be learned from these engineering solutions, and perhaps a more sustainable solution can be found going forward in the future, because in the coastal area of Bangladesh, this problem of water and soil salinity is only going to increase over time. So with this, I would like to finish my presentation, and happy to see if you have any questions or comments. Okay. Do we have? No, we don't have Professor Kazimuddin Ahmed. Oh, we do have. Yes. There you go. Welcome, sir. Professor Kazimuddin Ahmed from Department of Geology, Dhaka University. Would you like to share some of your experience from the Managed Aquifer Recharge project? You're still muted.
Yeah. Can you hear me?
Yes, we can hear you now.
Okay.
Welcome to our webinar, Professor Kazimuddin.
Thank you. Thank you for the invitation. And I'm sorry that I was traveling from work to home and it took longer than usual. So I missed most of your talk sounds, but I was able to listen to the last few points that you made. So I fully agree with Sams that this solution was technologically feasible, but sustainability is currently the main issue. So when it comes to soil and water salinity in the coastal area, so it has like manifold problems: water security, food security, environmental issues. So there are a number of issues. So various innovative approaches are being taken to solve these problems. So this initiative that I led with support from UNICEF Bangladesh and in collaboration with Acacia Water from Netherlands and Department of Public Health Engineering from Bangladesh, we tried to come out with a technological solution first. So the idea, some must have explained already, that to inject rainwater into the shallow subsurface, which is currently holding brackish water. Initially, the challenge was whether we'll be able to recharge any water out there. So we tried different designs and different levels of salinity. So we tried about 100 locations. We built these systems, Mars systems at 100 locations, having variable geology, variable salinity. Also, in some areas, there was problem with arsenic as well. So in most cases, we were able to reduce salinity to acceptable limit. Like we considered 2000 microsiemens or 100 or 1000 milligram per liter of TDS as the kind of standard. And in most cases, we were successful in lowering to that level. So that was one good news. But the problem is like how to keep them operational. So that was the major challenge. And another challenge that we faced is the demand supply scenario in the coastal area. So what happens during the monsoon time, there is plenty of rainfall and people fetch rainwater in whatever sizes of jars they can, and they use that for drinking purpose. So they don't want to pay, and then they don't want to take care of the systems. But the issue is that if they don't take care of the system during monsoon, and if there is no recharge during the monsoon, then there is no water left to collect during the dry season. So this was one of the major challenges that we faced, motivating the community that you have to store as much as possible during the monsoon so that you can extract during the dry season. So this was the problem that we faced. There is another issue is like continuous support, because some mentioned there is like operationally the MAR systems are not easy like the conventional tube wells. In Bangladesh, the rural area, tube well is the very easy way to collect water, where you have shallow aquifer containing fresh water or even deep aquifer containing fresh water. Using hand pump, they can collect water, and it doesn't need much of maintenance. But for this MAR system, this is an exception, so it needs continuous operation and maintenance, and they need operational expenses as well. One of the major issue for the tube well, you don't need a dedicated caretaker. Anyone from the household can do the minimum kind of maintenance. But for MAR, to keep them operational, you need a dedicated caretaker. It's not a full-time job, but you need to pay something to that person for keeping him engaged in the operation and maintenance job. So quality-wise, as I mentioned, the salinity, we are able to reduce it in most cases, except like we found some areas where grain size of the aquifer was very fine, so we are not able to reduce salinity there. And also in some cases, initial salinity was too high and we were not able to reduce that. So maximum that in our experience, what we have seen, electrical conductivity up to 12,000 or even in some cases up to 15,000 microsiemens per centimeter, we are able to reduce it to acceptable limit. So depending on like how much water we can recharge, how much time it took. So arsenic, in most cases, arsenic also decreased because of the dilution. But in some cases, in 2-3 cases, there was increase in arsenic. And one of the PhD student at Delft University, he is looking into that, what is the mechanism for this increase in arsenic. But in most cases, as I mentioned, it decreased. So this was very briefly my experience with this. I was very passionate about this research, and then the idea was that the people, their foods of water security can increase substantially if we can implement many of these, particularly in the most difficult areas where there is no other sources of drinking water. We tried another option, what we call the agri-MAR, so where you don't need that good quality water. So there was one trial only, so that can be used for not for rice irrigation, but for vegetable crops, homestead garden irrigation. So then there is that potentiality is also there. So, well, I would conclude saying that MAR has great potentiality in reducing water scarcity in the coastal area, as well as contributing to the food security of the coastal area. Thank you.
Thank you very much. And there are a couple of questions online, which I don't know, Mohammed, if you would like, or Shams, sorry, if you would like to answer by, I think the second one has already been answered by Professor Kazim Ater about the arsenic. I don't know, Shams, if you want to answer
Yes,
the first
yes.
one. Yes.
So the first question has been answered. So the question was whether organizations such as UN, WHO can support in
Yes.
practice effective resolution. Yes, my answer is we need more technical and financial support from the global communities, particularly the UN and other donors, to scale up some of these adaptation and mitigation techniques that we have been doing. And as you know, Professor Mateen has already mentioned, there are challenges in sustaining, which is a technologically and engineering uh, point of view quite sound solution to freshwater scarcity in the coastal areas. But because of socioeconomic and behavioral aspect, we are not able to sustain such systems. So we need more continuous technical and financial support from global community as well. Uh, in terms of the other question around the managed aquifer research project, yes, Professor Mateen has already responded to this quite sufficiently, so I wouldn't want to expand on it. The final question I can see, what about chemicals in soil and groundwater, example, arsenic? Question mark problem. Yes, as Professor Ahmed has already mentioned that in the coastal area of Bangladesh, salinity is not only an environmental issue, there is very high arsenic in some places, which is also quite concerning for freshwater supply point of view. Um, so what is the answer? I mean, I don't have the answer how to solve this problem, but just to acknowledge that, yes, there are multiple issues such as high salinity and high arsenic contamination in many parts of coastal Bangladesh as well. So I hope these are the questions I can see online so
I have
far.
another couple of questions
Please do go ahead.
if there are no other questions online. The first one is, I think, really about one of the comment that Professor Kazimatin mentioned about the fact that the people in the community are not necessarily willing to pay for the maintenance of these systems. And I just wonder if you have insight in the socio-cultural issues that are behind that attitude, especially in view of the fact that, you know, in our countries, we have all to pay for the water, for having, let's say, drinkable water, but also that here it's very much questions whether this system shouldn't be nationalized and, you know, shouldn't be a resource that is, let's say, free at the point of use for all. So, yes, please. I don't know if Professor Kazis
No, thank you. It's a very good question. Like, yes, that is one of the main issue. Like water in Bangladesh, particularly people in the past, like say that's now past 30, 40 years time, if you go back. So paying for water was kind of very, very unusual. So water should be free and you should get it freely. Because of easy availability of groundwater in other parts, it works because you have the simple technology, you can have your own well at a very low cost, even if there is no supply water. But the coastal area is very special. So it needs special care. And then I agree with you that people should get free water. So the systems that we planned was kind of small community level. We conducted some anthropological study as well. So what we have seen, we tried various different types of operational model. When we involved some institution, those systems function better than the one which were run only by the community. So some kind of institutional support makes them more sustainable. So this is very important. If it comes from either a government agency or an NGO or any other organization, I think that is very much needed to keep them operational and sustainable. And affordability is another issue. Because of lack of fresh water, the people in that region is relatively poorer than in the areas where there is fresh water availability. They can have like better agricultural practice, they have more better agricultural product. So they are better off than the people living in the extremely high salinity areas. So that's why I think some kind of I can link to the earlier question like about international support. I think there is if there is support from international community or agencies to keep them operational and make them bigger, maybe it is possible that through Mars system, even pipe water can be provided. So those kind of system, if can be built with support from international agencies, I think then it will be more sustainable, and then people maintenance will be done by the agency, whoever is responsible for operation. People may have to pay a very small amount, or if they are not affordable to pay any money, that they should get free water as well. So this is what I see as a kind of socioeconomic future for this Mars system. Thank you.
Thank you very much. I think there is another questions online, Shams.
Okay. Yes, from Richard Hughes. Do you have a problem of groundwater pumping from flood irrigation and then sucking down the salty surface water, so contaminating the deep groundwater? This occurs in Pakistan, also resulting in severe corrosion of pumping tubal structure. Yes, I can respond to this question. Yes, so particularly for the sucking the surface salt. Yeah, we in the coastal area of Bangladesh, most of the shallow groundwater systems, so the shallow aquifers have very high salinity. In coastal areas, generally people who can afford, they install very deep wells, so deeper than, let's say, 150, 200 meters below ground, that can have fresh water in there. So if I understood the question correctly, so the surface salty water, if you pump so I guess there is a concern of contaminating the deep groundwater because of seawater intrusion could be an issue. So if in the coastal area, people are generally using deep groundwater for drinking water purposes, once they start using deep groundwater for irrigation, then the increase of groundwater will be manifold, and that can endanger the deep groundwater because there may be saltwater intrusion coming from the sea, and that can contaminate the deeper groundwater system. Yeah, so I'm not sure if I have answered Richard correctly.
Yeah, let me add something on top of that. Yeah, the situation in Pakistan, this is a problem, we know that, but in Bangladesh, salinity is not there in groundwater for most part of the country. This is particularly a problem in the coastal area, and also climatically we are more wetter, and then there is annual flooding. So soil salinity buildup in the soil from irrigation water is less risk in Bangladesh than in Pakistan. And in the areas where the farmers use groundwater for irrigation is mostly fresh. It's very, very fresh water. So the risk of like vertical leakage of saline water to the deeper aquifer is almost low in the non-coastal area. In the coastal area, SAMS clarified that there is no shallow fresh groundwater. Deep groundwater is used only for drinking purposes. So the situation is, again, if they start pumping huge amount of groundwater from the deep aquifer for irrigation, then the problem will arise. Apart from saltwater intrusion, there's the risk of vertical migration of saline water to the deeper aquifer is there. So currently it's not there because there is not much irrigation obstruction in the coastal area. Thank you.
Yeah.
Thank you very much again. And then I will just run my last questions, which is actually fits perfectly after the question from Richard. So this specific problem that you have presented in great details for the coastal area of Bangladesh, how widespread is to other country in Asia with low-lying ground, or indeed in Europe? I think Professor Kazimaten was mentioning Delft and the Netherlands. So it would be nice to understand how related, or how similar certain situations are, and whether there have been considered other solutions.
Yeah, I can maybe briefly answer, and then Professor Ahmed can contribute. It is the problem that I described, the widespread soil and surface water salinity, as well as groundwater salinity in coastal Bangladesh, unique. We have similar situation in other South and Southeast Asian megadeltas. So, for instance, we have similar very high soil and surface water salinity in Mekong Delta in Vietnam, partly I think also Red River Delta in Vietnam. Similar problem is reported from the Chao Phraya Delta in Thailand, and also Indus Delta in Pakistan. They have similar kind of geological setting where soil and surface water salinity has been reported. So it is not a unique problem. It is quite widespread for some of the low-lying deltaic environment. European countries, but maybe Professor Ahmed, you can supplement because you have wider experience looking at soil and water salinity problem.
No, thank you. I agree fully with you, Shams, that this is a global problem. So this is not unique to Bangladesh. And also because of these climate change issues and larger amount of abstraction of fresh groundwater, the delta regions are becoming more vulnerable or more prone to salinity intrusion. So that's why this is not a unique problem. So this kind of in Spain, they have tried managed aquifer recharge. In the Netherlands, in some parts, they have similar things. So in the project that we worked with our Dutch colleagues, so it was kind of cross-learning from each other so instead of high-tech in Europe, normally they use high-tech things. So in Bangladesh, we tried to use very low-tech thing and locally available thing at low-cost solutions. So we can actually learn from each other and work together in solving this problem. This is already a major problem, and it will continue to grow because of climate change, sea level rise, and other issues. Thank you.
Yeah.
Thank you very much. Yes, thank you for also giving the more global perspective. Yeah. I don't know if there are other questions from the audience or from our other colleagues, Rafael and Sishan.
I don't see any questions online. Yeah, there are some people in the audience. If there are any kind of last comments or questions, then Professor Ahmed and I are here to respond.
if everybody is content with the listening and a very, very good presentation by Dr. Shams Mohammed, which we really very much enjoyed. And thank you again for Professor Hamed to manage to, notwithstanding traffic problems, manage to link and join us on these very interesting discussions. I will pass the mic back to Rafael, who started the conversation today. So please, Rafael, send us on for Christmas at this point.
Thank you very much, Dina. Thank you, Shams. Thank you, Professor Martin. It was a pleasure to have you both here with this interesting webinar. Just to mention to our audience that we have a series of upcoming webinars that you can find in our webpage. And with that, Merry Christmas to all that are celebrating, and enjoy the holidays, and hope to see you all soon. Thank you very much.
Thank you.
Thank you,
again
everyone. Bye-bye.
for this talk.
Bye-bye.
Thank you very much.
Bye-bye.
Bye. Take care, everyone. Bye.